Good afternoon, everyone. It's a pleasure to welcome you to the online seminars in psycholinguistics. Thank you for being with us today. I am Mayusi Mota, professor at the Federal University of Santa Catarina, UFSC, as we call it, where I coordinate the Language and Cognitive Processes Lab. This lab is affiliated with the graduate program in English and the graduate program in linguistics at UFSC. So with Professor Pamela Toassi from the Federal University of Ceará, where she coordinates the bilingual and multilingual language processing research group, we are starting these online seminars in psycholinguistics. The bilingual and multilingual language processing research group, coordinated by Professor Pamela Toassi, is affiliated with the graduate program in translation studies at UFSC. At the Federal University of Ceará. So the seminars consist of a series of talks related to language learning and processing, including the psycholinguistics of translation processes. So all talks will give you certificates, and to ask for a certificate, please fill in the Google form that will be available in the link that we will post to the chat throughout the talk. To start the series, we have the honor to welcome Professor David Peeters from the Department of Communication and Cognition at Tilburg University, the Netherlands. In his work, Professor Peeters makes use of immersive virtual reality technologies to study human linguistic and communicative capacities in rich and dynamic audiovisual contexts. More specifically, he applies virtual reality in combination with motion tracking, eye tracking, and EEG to learn more about the cognitive and neural underpinnings of language and communication in domains such as neuropragmatics, multimodal and nonverbal communication, and multilingualism. He got his PhD from the Max Planck Institute for Psycholinguistics in the Netherlands, and he's currently funded by a very prestigious grant, the Veni Grant, from the Dutch Research Council, which is the most important state-funded organization that provides research funding in the Netherlands. Also, Professor Peeters is an avid reader and a lover of literary genres. During the talk, you can post questions and comments to the chat, and I'll pass them on to Professor Peeters, and he will be happy to discuss your questions and comments. So, David, thank you so much for accepting the invitation to open our online seminars in psycholinguistics. Over to you now.
Thank you very much for this very nice introduction. Let me try to share my screen with you. Yeah, there we go. Yeah, so thanks a lot for this invitation and for this very nice initiative of having this series of talks. And it's a great honor to be the first speaker in this series. So as I said, I'm working in Tilburg University, which is a university in the south of the Netherlands, so in Holland. And here you see a picture of our campus. But unfortunately, I should say also since the middle of March already, I haven't been there, of course, because of the crisis. But I can assure you, over time, things will become better. So hang in there, and I hope you're all doing well and staying healthy. And here, once the peak is over, things will look much better again. So I hope that will be very soon. So today in this talk, I hope to present you some of the research we have been doing about multilingualism, and specifically in the domain of bilingual language production. Right, so if you think of everyday communication, everyday situations in which we use language, then you might think of situations like the one you see here. So very rich situations are often very dynamic and communicative, where many things are going on at the same time. Of course, those are three-dimensional situations in which we communicate not just via speech, so not just auditorily, but also visually, for instance, via the hand gestures that we make, and also via facial expressions. So you could say this type of communication is multimodal. So we use different modalities to communicate, to get our message across. Now, if you then think of the typical experimental situation in which often as an experimental language researcher, we collect our data, then they might often look a bit like this. So participants are placed individually in front of a computer screen, often also in a soundproof booth even, where they don't see anyone, they just see a computer screen. And those situations are often, of course, very static and repetitive. Often the tasks they have to perform are non-communicative. So if they have to speak, for instance, they just speak into a microphone and they don't speak to a person. Stimuli are often two-dimensional, and often they just have to use one modality, so only speech or only gestures. Not very often there's a combination of all those things together. So it seems that there's quite a gap between, in the end, the thing I think we should be interested in, which is language in the everyday world, everyday communication, and the kinds of situations where we collect our data to build our experimentally inspired theories on. Now, if you ask someone, ask an experimental researcher like myself, why are you collecting data in those very impoverished lab situations? Then someone like me would say, or at least in the past, well, of course, we need a lot of experimental control to collect reliable data, to robustly collect the data about this one variable that we're interested in. And experimental control and ecological validity, on the other hand, are sort of the two ends on a continuum. So we would like to have our paradigms be a bit more naturalistic, to be a bit more rich, but we also want to have experimental control to collect reliable data. And if we make our paradigms less controlled, to make them a bit more ecologically valid, we will lose the control that we need to collect this data. And I think this idea is also very intuitive if you think of the different methods that people use in the language sciences. So of course you have methods like conversation analysis, where people just videotape language users, and then afterwards they analyze what those people have been saying in conversations. Here, of course, the ecological validity is very high. So people are really behaving in a natural way, and that's what's being analyzed afterwards. Whereas if you think of many computer experiments that we're doing, you could say we have a very high degree of experimental control, but perhaps those paradigms don't have much to do with everyday situations. So if you think of the different paradigms that we use, you could say, well, maybe they can all be placed more or less somewhere on this continuum. Now, recently, actually, more and more people have started arguing that those very strict experimental paradigms that we used might be a bit problematic. So for instance, people have said things like, those findings that we obtain in those restrained lab settings, they may not really generalize to real life. Or people have said about language comprehension, we know, of course, that usually it's situated in a very rich context, but this is not what has shaped our theories. Our theories are really built on those more impoverished experimental paradigms. And other researchers have called this passive spectator science. So our participants in those strict experiments, they're really passive spectators. They just come there to do this experiment and they're quite passive, which is of course very different from everyday life in which we use language in a very active and interactive way. So it seems that we should try and do our best to make our experimental paradigms a bit more natural, a bit more naturalistic. But on the other hand, we also need this experimental control to collect reliable data. So it seems like this is a problem that we cannot very easily solve. Now, what I will propose is that actually this is not a problem in practice. It only seems a problem. So I think what's actually going on is that those two constructs, so ecological validity, how natural your paradigm is, how much your paradigm actually generalizes to everyday situations, and experimental control are two constructs that are more orthogonal. And then ideally, your experimental paradigm should be somewhere here, such that you combine the best of both worlds. So you can have both high ecological validity and also high experimental control. So I'll try to convince you that virtual reality should be one experimental method that could be placed in this part of the graph, but you can have the best of both worlds. So you can have both high ecological validity, so quite naturalistic situations, and still you can have the experimental control that you need to collect reliable data. So just a bit of background about this relatively novel method of virtual reality. So the basic principle behind it is actually already very old. So the basic principle is that one's physical location not necessarily corresponds to one's mental location. So this, for instance, holds in the cases of dreaming or mind wandering. So physically, you may be in one place now, but if you think this is a very boring lecture, your mind may wander off and you might be mentally in a very different location, right? Also, many different types of art. This principle plays a role, for instance, movies or paintings or music. Also literature, so you might be reading a novel on your couch, but mentally you might be in a completely different place, so taken to a different place. Also, very immersive computer games can do this to you, right? You might be physically playing this computer game in your room, but mentally it might take you to a completely different world. I think virtual reality is just a relatively new method, paradigm, where also this basic principle actually holds. So you may be physically in one place, but mentally you might be transposed to a different situation. Now this method actually comes in two basic flavors. So on the one hand, we have head-mounted displays. So you might be familiar with those. So those you place on your head, and you no longer see the actual world, but you see a virtual world that has been completely programmed. And you can look around you in 360 degrees, and you become completely immersed in this different world. And those are very nice also to take to places. So you can use those to do research sort of in the wild. So we've been using those going to libraries in the Netherlands, where we asked visitors of the library to wear those headsets, and then they would be immersed into a different world. So this is, I think, one type of virtual reality. So the advantages of this flavor are, of course, there's a high degree of immersion. So you really completely no longer see the actual world around you. And it's also nice to combine with, for instance, EEG, if you would like to measure brain activity. And the second type of virtual reality is can be taking place in so-called cave environments. So this stands for Cave Automatic Virtual Environment. So in those kind of cases, you would actually still go to a lab, and then on projection screens, so on large screens or on walls, a virtual world would be projected. And what you can do then is also record EEG in those environments from the participant, and participants wear those 3D glasses such that everything that's projected on those walls or on those screens is experienced in 3D. So they really feel like they get immersed in this virtual environment. And here's an example from a recent study that we did. So here you see these large walls. Now from behind, we projected a virtual world onto those walls. And participants were actually walking on a treadmill on a virtual road. Then we can measure things like their eye movements to see what they're actually looking at. And while they are walking, actually this virtual world also comes towards them as if they are in this different place. So in this specific example, for instance, we were interested in how people perceive the world. So we wanted to do an eye tracking study. But it's hard to do this in the wild, right? To send somebody outside with an eye tracker on their head. So here in this more controlled in-lab environment, we could more easily do this. Here's another example where two participants are in the lab in a forest. So typically they would also wear those 3D glasses such that this forest that they see is also in 3D around them. And then they could perform any kind of interactive task there. So there could be all sorts of animals popping up. And then they could be talking about those animals, for instance. Right, so those are the two basic types. So on the one hand, those head-mounted displays, and on the other hand, those cave environments. And I think those methods have quite some advantages for the language sciences. So the nice thing about this is that you can study fundamental questions about language, but still looking at real-world phenomena. So as I said, I think it nicely combines ecological validity with experimental control. And also it allows for a nice repeatability or replicability of studies. So in the past, often researchers have also tried to make experimental paradigms a bit more interactive. For instance, by having a confederate and having, for instance, a dialogue setting in the lab. But now if you would do this in virtual reality, what is very nice is that you can simply send your virtual environment and your virtual experiment via email to a different lab. And there they could carry out the exact same experiment in the same environment with the same confederate. So also in terms of replicability, I think this is a nice method. Right. So over the past years, we have used this method to study different issues related to language. The issue we will talk about today is related to bilingual language production. But we've also done studies on the influence of language on perception, also on the role of prediction during language comprehension. We also looked at how people integrate hand gestures with speech while they are speaking or when they are processing hand gestures and speech at the same time. We also looked at how people process facial expressions, and we even looked at how people appreciate poetry. So there we had people literally step into a poem. So they listened to a poem with this virtual headset on, and then they saw a virtual environment that sort of resembled what was expressed in the poem. So those are all sorts of topics we use VR for. But today I'll focus on one issue to go into this issue a bit more deeply than when I would just briefly mention all of them. If you have questions about one of those other topics, feel free to always contact me or ask a question about it. Right, so let's now focus on bilingualism and bilingual language production. So sometimes, I think for this audience, this is not necessary, but sometimes people ask me, why would you study bilingualism? Why wouldn't you just study monolinguals? Because aren't most people monolingual anyway, and why are bilinguals? Why would they be so different than monolinguals? Well, one reason, obviously, to study bilingualism or multilingualism is that actually more than half of the people in the world actually speak more than one language. And in a lot of research about this, you're already considered a bilingual, also if you don't master this language perfectly, if you don't master this second language perfectly. So you could say bilingualism is the norm. So if we want to learn something about language, we should maybe study bilinguals rather than monolinguals. There's some nice, exciting findings also related to bilingualism. So some studies have found that bilingualism even postpones the onset of dementia with a couple of years. So also from a practical and societal viewpoint, bilingualism is a nice topic to study. And you could say that language switching and language control, the processes that are sort of going on in your mind, in your brain, to make sure you keep speaking the right language in the right context, sort of keep your brain in good shape. Right, so today I'll focus on bilingual language switching, how bilinguals switch between languages. So very often, of course, people who master more than one language have to switch between languages. For instance, this guy here might be familiar to you, Guga Querten. Of course, after a match, often he has to switch between different languages during interviews, switching between an interview in English to another interview, perhaps in Brazilian Portuguese. And sometimes when bilinguals switch between languages, this is even within the same sentence. So here in the Netherlands, this I often overhear this when I'm sitting on the train. So then people are having a conversation, for instance, in Dutch, and then all of a sudden, within a sentence, they switch to a different language. For instance, because certain concepts might be expressed more easily in the second language, in a different language. But of course, people also switch between speakers. So now we're speaking English, but maybe afterwards I might be speaking a different language again. So that would also be a switch from one language to another. So question in this field then is, how do bilinguals select the right language to speak? How do they make sure that they keep speaking in the language that is appropriate in the context that they are in? So in other words, what are those control mechanisms involved in bilingual language production? So based on previous research, you could say that there are two main mechanisms playing a role. So one mechanism is called reactive inhibition. So it's inhibition because one language is assumed to be suppressed or inhibited for a certain amount of time. And this is evident from so-called switch costs that have been found in psycholinguistic paradigms. So there the idea is if there's a certain cue or if there's a certain trigger to switch from one language to the other, you would start inhibiting the language that you don't use. So if I now all of a sudden I'm going to switch from English to Dutch, I need to quickly inhibit, suppress English to be able to speak in this other language. And then there's a different related mechanism, which is often called proactive inhibition of the more dominant language. So here the idea is if you know that you're in a situation where you have to switch between languages and you're more dominant in one language than in another, you can already proactively inhibit your more dominant language such that you become a bit more fluent, a bit faster in your second language that you might be not so dominant in, not so proficient. And this is evident from so-called reversed language dominance effects in psycholinguistic studies. So in several studies, it has been found that actually people who master one native language, who are very good in speaking their native language, and are a bit less good in their second language, their non-dominant language, still in the lab, often they become faster in their second language than in their first language, even though their first language is much stronger, they're much more proficient in it. So this is called reversed language dominance. And this has been taken to show that apparently it's possible for a longer amount of time to really proactively inhibit your stronger language. All right, so those are, I guess, the two main mechanisms that have been proposed to be involved in how bilinguals manage to switch from one language to the other. And let me show you a paradigm that is typically used to study this in the lab. So in a typical study, like a very seminal, important study by Muter and Allport at the end of the 90s, they would have, for instance, 16 unbalanced bilinguals come to their lab. So those are called unbalanced because they have one strong dominant native language, and they're a bit less good in their second language that they learn later in life. And those bilinguals are asked to take place in front of a computer screen and to simply name digits or numerals that appear on a screen, either in their first language, L1, or in the second language, as a function of a color cue. So in their case, this was a colored rectangle. Often also flags are used or background color of the screen. So this paradigm typically looks like this. So you see a certain number on the screen, and in this case, there's a blue rectangle around it. And prior to the experiment, you have been informed that if there's this blue rectangle around it, you name this digit in your first language. So if your first language is English, then here you would say 4. Well, then on the next trial, apparently again, there's a blue rectangle. So again, you would name this digit in your first language. So if that's English, you would say 9. But then on the next trial, there's a different color. And you've been instructed that if there's this yellow rectangle around the digit, you name it in your second language. So if your second language is French, you would say here, tank. Well, then the next trial, there can be a blue rectangle, so a native language trial again. And like this, what you actually get is so-called non-switch trials, where you use the same language twice in a row. But you also have those switch trials, where you switch from one language to the other. So this could be from your first language to your second language, but also from your second language to your first language. And then, of course, also there will be non-switch trials in your in your first language, in your second language. So this is really a perfect 2x2 design. Either you switch between languages or not, and either you speak in your first language or in your second language on a certain trial. Now, I've also been doing those experiments myself, so let me again show you what this looks like. So here in this first experiment that I'll show you, we invited 24 unbalanced bilinguals to the lab, and their native language was Dutch, and their second language was English. And here in the Netherlands, most of those students, they started learning English at the age of about 8 or 9. But Dutch is really their stronger, more dominant language. And they're quite proficient in English, but not native-like. So here we had them do a cute picture naming, and then we measured how long it took them to name those pictures. So for instance, they would see a fixation cross first on the screen, and then they would see a picture. And in this case, there's a bluish background color. So they would know, they hadn't been instructed before that if there's this blue color, they should name this picture, for instance, in their first language. And then on a later trial, there could be again a picture, but now there would be a different color. So then they name this picture in their second language, for instance. And then those color cues, they're counterbalanced. So for half of the participants, this color stands for their first language. And for the other half, the color stands for the other language. And like this, we measure how long it takes them to name those pictures. And then this is what we typically find. So this is picture naming latency. So the interval between seeing a picture and starting to name it. And here there are two main findings. So one finding is indeed those switch costs. So what you see here is that actually, oh, nice, I have a mouse. So what you actually see is that switching trials, so the green bars here, actually elicit longer reaction times than the reddish bars. So those are those switch costs. Another thing we find is actually this reverse language dominance. So here on the right, you see people's native language Dutch, but actually it takes them longer to name those pictures in Dutch than it takes them to name those pictures in their second language, English. So very counterintuitively here, they're faster in their less dominant language, English, than in their native language, Dutch. Right, so two main findings. The one is the switch costs. So switching languages takes longer than just continuing to speak in the same language. And overall, participants are faster in their less dominant second language. So this is nice. So this confirms those two mechanisms that were proposed. But of course, people start criticizing those methods. So what other researchers have been saying are things like, well, this language switching in the lab, of course, it doesn't reflect everyday intentional language switching, right? I think this is a fair point. With computer paradigms, they are nothing like switching languages in everyday life. Those switch cues, like those colors, or sometimes people use flags or very artificial cues. If you all of a sudden see a certain color in everyday life, you're not all of a sudden going to change the language that you speak, right? So language switching in everyday life is not induced by those artificial cues. So perhaps those cue-induced switch costs might not have anything to do with everyday bilingual language production. So I think this is quite problematic if this is the case, because this means that the theories that we have about language switching might not be relevant to everyday situations. So we turned to virtual reality to see if we could make this paradigm, the switching paradigm, step by step, a little bit more natural. So as a first step, what we did is actually we did exactly, or more or less exactly the same experiment, but now we did it in virtual reality. So participants were wearing this headset, and then they would do this switching task simply in a virtual environment rather than in a real environment. And the idea was we do this very baseline experiment first, just to see whether wearing this headset already changes something. Usually, it would be nice if it doesn't, but it could be the case, for instance, because of novelty effects. Perhaps because people don't usually wear those headsets, this might be so novel to them, they might be more motivated, more excited, and this might already be changing the results. So we did this first. So participants were wearing this headset, and then they would be in a virtual room where they would see a virtual screen. And now pictures would just appear on this virtual screen. And behind this screen, there were two color cues. And on every trial, one of the two would sort of light up. And that would be the cue for them to say, okay, now name this picture in one language or the other. Well, so we did exactly the same thing as in experiment one in the second experiment. And we found the same results, actually. So simply doing the same experiment in VR versus doing it on a computer screen doesn't change the results. So here we again found those switch costs. So switching comes at a cost. It takes some time to switch between languages. We also again found that people were faster in their less dominant second language compared to their native first language. So that's good. So because that means simply doing this in VR doesn't change anything. So now we can start making this paradigm a bit more natural to see if that will change the results. So the first step, what we did was we tried to improve the ecological validity of this paradigm. We invited another different 24 unbalanced bilinguals to the lab. And now rather than speaking to nobody, which they did before, there would actually be two listeners for them. So there would be one English listener and one Dutch listener. So before the experiment, one of those two avatars would look at the participant and she would introduce herself. So the English avatar, for instance, would say, hello, my name is, and then a very English British name, like Rosie or something. And she would say, I only speak English. So if I look at you, please name this picture for me in English, because I only understand English. And then the other avatar, which looked very similar, prior to the experiment, she would say the same thing, but then in Dutch. So she would say in Dutch, hi, my name is, and then a very Dutch name. And then she would say in Dutch, if I look at you, please name this picture for me in Dutch, because I only understand Dutch. So like this, as a sort of first step to make this paradigm a bit more natural, we made sure that people were actually talking to listeners rather than just talking to nobody, right? Because in everyday life, you're also almost always talking to somebody, right, when you're talking. So then the idea was, will this first step already change those results or not? Well, actually, it didn't change the results at all. So again, we measured how long it took people to name those pictures. And again, we found those switch costs. So it took people longer to switch languages than to repeat, so to not switch languages. And also, again, this different group of unbalanced bilinguals, again, they were faster in their less dominant second language than in their native language, Dutch. Right, so then because we wanted to be sure of those findings, we replicated this experiment. We just simply did the exact same thing again with a different group of participants. And again, we found the same thing. So again, we found this reversed language dominance. So people were faster in their in their second language than in their native language. And again, we found those switch costs. So then in total, in all those 4 experiments, we actually found the same pattern. So overall, some participant groups were overall a bit faster than others, but in all cases, there was this reversed language dominance. And in all cases, there were those switch costs. So on the basis of those findings, you could say, okay, if we make this paradigm a little bit more natural, such that participants actually have somebody to speak to, that they name those pictures with a reason, then actually we still find those same things. So this might indicate that those theories that we have about switching between languages, that it has to do something with inhibition, might actually be relevant for everyday situations. But now you might think, of course, isn't there a confound between switching between cues or listeners and switching between languages? Because in those last experiments that I showed you, whenever participants were switching between languages, they were also switching between listeners. So perhaps just switching from one listener to another already leads to a switch cost. It's already a bit more difficult than just keeping to speak to the same person all the time. Right, so this is something we then also tested, and this we tested in this cave environment. So we no longer use this head-mounted headset, but we use this cave environment. And here we did 2 experiments that both actually show the same thing. So I combined them here into one data set. And here we didn't just record picture naming latency, so not just reaction times, but also EEG in this lab. But I won't show you the EEG results because they simply show the same thing, as the same pattern as the reaction time results. So here what we did is we had, rather than having 2 of those listeners, we had 4 different listeners. And then as you might have guessed, 2 of those listeners were speaking only Dutch or understanding only Dutch, and 2 of those listeners only understood English. And this allowed us to disentangle switching between listeners from switching between languages. So now what you could have here is a switch between listeners in the same language. And you could also have a switch between listeners, but then at the same time switching between languages. So here again, at the start of this experiment, all those 4 listeners introduced themselves. So 2 had very typical Dutch names, 2 had very typical British names. And then they said, well, I only understand Dutch, or I only understand English. Please name those pictures for me in one language if I look at you. Yeah, and then participants look like this. So they wear those 3D glasses. So everything they see in 3D. So here this scene really sort of comes towards them. It's really as if they're sort of sitting at this table. And we, as I said, we recorded brain activity at the same time. So let me walk you through the results for this 5th experiment. So this is what I'm first showing you. This is the very same contrast that we saw before. So here again, you see language. So those are reaction times again. And again, people are actually slower in their native language than in this second language that they started learning in school. Just plotted the other way around to try and keep you awake. And again, you also see those switch costs. So here we are comparing trials on which participants did not switch. So those are in red. Two trials where participants switched listeners and languages at the same time. So this was the same as in the previous experiments, and we also found the same results. But what we now can also look at is the so-called listener switch cost. So here in all cases, there was no switch in language, but in the blue bars, there was a switch in listeners. And what those results actually show is that if you're simply switching from one listener to another, but you're staying in the same language, already this leads to a cost. So it's talking to some person, and then talking to a different person, already this comes at a cost, regardless of whether you're switching languages at the same time. But then the final comparison shows actually what you could call a more pure language switch cost. So here in all cases, there was a switch in listeners. It's just that when there was a switch in listeners plus a switch in languages at the same time, it led to a larger cost than where you were just switching listeners within the same language. So on the basis of those findings, you could conclude, well, switching languages comes at a cost over and above the significant cost of switching listeners. So again, this sort of might suggest that indeed the switch cost and also this reverse language dominance might have some relevance for more everyday situations where you're switching listeners sometimes and when you're switching listeners and languages at the same time sometimes. All right, to sort of wrap those 5 studies up nicely together, what we find is this sustained inhibition of the native language. So apparently it's possible to really inhibit your native language for a longer period of time to become a bit more fast, to become a bit more fluent in your non-dominant second language. For those participants, they were, of course, very good in their native language, Dutch, a bit less good overall in everyday life in their second language, but because they knew that they would be in this dual language context, apparently they're capable of inhibiting their native language such that they become faster in their second language during those experiments. And that was shown by this reverse language dominance. And then apart from that, what we also found is that switching between languages reliably really comes at a cost in those paradigms. Right, so I think this shows some ecological validity of the traditional paradigm, but of course, those are just the very first steps. I think this is a nice basis for more interactive and more immersive paradigms. So now in those paradigms, it's nice, I think, that we have a listener, so participants are no longer speaking to nobody, but they're speaking to a person. But of course, this is still far away from everyday dynamic situations, right? So what we're doing now in ongoing work is we're really trying to make this environment much more natural and much more rich. So what we're doing now is that participants come into this cave lab and they are told that they are now shopkeepers in a fruit and vegetable shop. And then customers actually come towards them with a piece of fruit or a vegetable that they want to buy. And then the participants actually have to say how much that piece of fruit or vegetable actually costs in a full sentence. So now we have a much richer environment where there's visually much more going on. And instead of just naming pictures in single words, they are now producing entire sentences. So by making this visually more rich, I think this sort of improves the ecological validity more. And by moving from the individual word to the sentence level, we also make this much more natural than the previous paradigms. So here participants could say something like a peach costs 70 cents. And now it's more or less looks a bit like this through those VR glasses. So imagine you wear those glasses in this lab with these large screens, and then you see this nice marketplace where you're a shopkeeper, and then a certain customer comes towards you, and you know all the customers beforehand. So you know some will speak one language, only speak one language, and others only master the other language. So then if one of those comes up to you with a certain piece of fruit or vegetable, you will say a sentence, in one language, and then we're going to look whether this now takes longer when you're switching between those different customers, using full sentences in this very rich environment where what you say actually also now sort of has some communicative value to your customers there. All right, then now this is my final take-home message overall, looking beyond bilingualism. So I think in general, what this new method shows is that ecological validity and experimental control are not two extremes on a continuum. It should be possible to sort of have the best of both worlds. I think it offers unique opportunities for the language sciences to make our paradigms a bit more resembling a bit more everyday natural situations while still having this control that we need, for instance, to record brain activity. And I think theoretically, this might shift our focus a little bit towards the interaction between different modalities, so speech, hand gestures, eye gaze, facial expressions, studying all those things at the same time in the same experiment, rather than only looking at speech in one experiment and then looking at, for instance, facial expressions in a different experiment. And also, I think it will lead us a bit towards studying interaction with the non-linguistic environments, which is also, of course, something we very commonly do in everyday life, where we are talking about things that we see around us and the objects that we interact with. All right, if you want to read more about this, there are also the papers that you can read. And yeah, let me thank you a lot for your attention. And I would be very happy to answer any kind of question that you might have.
Okay. Thank you so much, David. So you're, yeah. Thank you so much, David, for this very informative and inspiring talk. So it's really exciting to know more about this possibility, right? So we have many questions here. I will pass them on to you in the order that they appeared.
All right.
Right?
Mm-hmm.
So the first one, do you think, no, Professor Peeters, would virtual reality be an option for language learning and teaching?
I see, yeah. I'm not studying this myself, but I know there are people who are doing this. So I think there's, for instance, Professor Ping Li, who did quite some research on this, on how you can actually learn or teach a second language in this virtual environment. I think a very nice aspect of this method is that you can learn this second language in a different place. So say you want to learn French, then of course you could go to France, take a plane, go to France and learn it there. But if you have this headset, or you have a phone that you can use with a headset, then actually it might be much easier to get immersed in a different foreign environment and still learn this foreign language there without actually having to move to a different place or even by having to go outside. So I think that's one possibility. So the visual environment in which you use language, in which you learn a language, you can change. Another thing is that you could ideally interact with a virtual person who speaks the language that you would like to learn in this virtual environment. So, of course, usually if you want to learn the language in a fast and efficient way, you would speak with native speakers of that language. But of course, those are not always available, right? Whereas virtual agents, if they are trained to teach you a certain language, they might be always available. So you can be instructed by them also at night or over the weekend, just whenever that's convenient to you. So I think in this way, there are two main opportunities. One is very rich visual environments in which you could learn a foreign language without even having to go outside. The other is those virtual agents that you can sort of interact with in a foreign language that you can always ask for help whenever you would like to practice.
Okay, thank you. Besides virtual reality, which methods do you think may have greater ecological validity than the common controlled lab settings?
Okay, yeah, thank you also for that question. I think ecological validity is quite a tricky concept. So I think it really depends on what you're studying. So if you're interested in, having a theory about everyday language, then I think virtual reality is a nice method. But of course, also there are people who are studying, for instance, reading. So if you're studying how people read words, of course, probably you wouldn't need virtual reality. So it really depends a bit on what method that you have. I think in many cases, a combination of methods is very nice. So I think that would be an ideal world where some researchers are studying a phenomenon really in the wild by using conversation analysis, getting insights, really looking at very rich everyday situations. On the basis of those observations, you can have certain hypotheses that you could then test in an experiment. And perhaps next to that, you could use computational modeling to see how those different factors interact with each other in a more formal computational way. So I guess that would be my answer. On one hand, it really depends on your research question, what method would be most suitable. And in general, I think using different approaches, observational, experimental, computational together, that might lead to most insights about a phenomenon that you would be interested in.
Yeah, perfect. In your opinion, what would be the challenges of using VR in psycholinguistic studies?
I think, well, I think I've come across quite some challenges over the years now. Some are just practical, right? So those headsets now, they become quite affordable, and more people also would have them at home. But still they're quite costly, so that's, yeah, quite a practical thing. Now, of course, in this COVID period, in the past, what we would do, we would just put one headset on a participant's head, and then we would clean it a little bit before the next participant comes. But this is now very problematic, right? So it's not sure whether we can do this type of research in the coming months, for instance. Other challenges are, I think, convincing people that indeed this is a valuable method. Some people just, especially when they haven't experienced it themselves, because I think if you experience this method, it's really a strong experience. So you really feel like, oh, okay, this is really like a real situation. But if you haven't really experienced this yourself, it's sometimes hard to sort of convince people that indeed this might be a valuable method. So. And in general, there are some, it just takes some time to build those experiments. So if you do a simple experiment on a computer screen, you might need to look for stimuli and carefully match those. But the richer you make your experiment, as we're trying to do, the more time it just takes to build those experiments. So you need someone who has graphic design skills to make those nice environments, and you need some programming skills. So therefore, also what we're always now trying to do is that once we have developed those visual materials, like a nice visual environment or those 3D objects, we typically just share them with the publication, such that also other people can just use them, because it takes quite some time to like build a virtual room, to design it, or design a virtual forest. You really need someone who is trained for this and who has a lot of time to make this. I think now this becomes more and more available. I hope more people will also start using it.
Yeah, so this has to do with the next question, which was about the disadvantages of the methods. So we would say the cost, then the amount of work that's necessary to design the environments.
Those could be considered disadvantages. I think the disadvantage should always be seen in the light of the research question that you have. So for some research questions, this might not be the ideal method at all. So you wouldn't even think of disadvantages, but you would just disregard it completely. Yeah, and I think a disadvantage, as I said, is this using this method in times of COVID, because people have this on their heads. So it's really hard to collect some data now.
Okay, so yeah, so that's very nice, because the other question was if virtual reality would be an option for learning and teaching in pandemic times.
Yeah,
because it allows remote interaction.
Exactly. I think in theory, definitely. So there are, you can go, you can all sit in a different place in a country or in the world or in a city, all wear a headset, and virtually you can be in the same place. It's just that in those kind of situations, and everybody needs to have their own headset at home. If you want to really have this 3D experience, which can be very much like an actual classroom, it's just very costly. Yeah, so that I think then it's relatively more easy to have more like a 2D variant of that still on a computer screen, where also you might have your own avatar in a 2D environment where you can walk around to still sort of mimic your actual classroom in a digital way.
And then concerning the participants' comfort, are there limitations on using VR for experiments?
Yeah, so in the past, what sometimes happened was that there was this called simulator sickness. But this in recent times. Now this technology has advanced quite a bit. This has become very rare. So I think maybe 1 out of 100 participants doesn't feel too comfortable wearing those glasses and might get a bit sick. So this is something that you should always immediately test at the start of your experiment. We always test this by having we have a technician in the lab who really quickly gets sick. So even if he sits in a car or something, he gets sick. So we always test everything on him. And then if it's fine for him, then we know that everybody more or less can do it. But apart from that, I think there are mainly advantages in terms of comfort. So usually in those traditional experiments, participants would get quite bored quite quickly if they have to do the same thing over and over again. And now for those experiments, they actually mostly really like it because there's more to look at. There's sort of a new experience. So they're a bit less bored than they usually are in those psycholinguistic tasks.
Okay. Now, moving on to the experiments that you showed. So the mechanisms, reactive inhibition, and I think proactive inhibition, there were 2 mechanisms, right? So do these mechanisms also affect in the writing process in a second language?
Oh, I see. Oh, interesting question. I've never studied writing, but I think that's an excellent question. I think it must be the case. So if you think of the lexicon that we have as being relatively shared across the different modalities, so across speech or writing, then I guess similar things should be going on, such that if you have the task to write in a second language, you should inhibit your native language when doing so. So if you want to express a certain concept in one language, you make sure that you're going from concept to the lexical forms that you have in your memory towards articulating it, either via speech or via writing. Yeah, so I've never come across actually in study looking into that, but I also didn't specifically look for it, but that might be a very interesting project to work on to see whether similar things are going on when you have to write rather than when you have to speak.
Thank you. Fear and other emotions related to games could interfere in the cognitive processes going on during the task that you're.
Yeah, so in those kind of experiments that we do, we always try to have very neutral environments where people are very comfortable and nothing weird goes on. I know virtual reality is also used quite a lot for treating phobia. So if you have a certain phobia, so for instance, you're afraid of spiders, then what would happen in the past is that you would get exposure therapy. So you would be slowly, during every therapy session, you would be exposed a bit more to the thing you were afraid of. If you're afraid of spiders, for instance, perhaps during the second therapy session, you would see a picture of a spider or drawing. And then if that goes well, then in the next session, you would maybe see a toy spider. And then in the 5th session, you would see an actual spider very far away from you. And then over time, because of this exposure and because nothing bad happened to you, then people sort of often get rid of their phobias. But of course, this is quite limited in terms of what you can do, and sometimes it's also dangerous. For instance, if people have fear of heights, then for exposure therapy, what would work in theory is that, like, for instance, every session they go to a bit higher place. But then if people still get very scared or get some kind of panic attack, then this might be dangerous if you're on top of a building, for instance. Now, for those kind of therapies, virtual reality is also used quite a lot, such that you can get this exposure therapy in a virtual environment where actually nothing bad can happen if you would sort of react to it. I don't know if that's completely an answer to the question, but I think in those psycholinguistic experiments I showed, we make sure that nothing is scary at all. But there is a big field of people researching how people respond to things they are afraid of.
Yeah, so we have many other questions. Can I go on?
Yeah, sure, just go on.
Okay, so yeah, a little bit about neuropragmatics and how VR is changing or shaping the field.
Yeah, I can think of a couple of studies. There's one PhD thesis by a former PhD student who looked into the processing of indirect requests. So their very typical indirect request would be something like you're feeling very hot, but then rather than saying I feel hot, you say something like the window is closed. So that would be a very indirect way of saying, can you please open the window? Or if you're in a restaurant, something very indirect you could say would be my soup is cold. So that would be a very indirect way of saying to a waiter or waitress, can you please get me some new soup? So those indirect requests, they have now been studied in virtual reality. So there, what we did is we built a virtual restaurant, and then participants were working in this virtual restaurant. And then every now and then, a customer, so a restaurant guest, would say something either directly, something like my soup is nice, or they would say something like very indirectly, like my soup is cold. And then we would compare those different situations to see whether it's more effortful to process indirect speech acts compared to more direct speech acts. So I think that's one example of where VR is being used in the field of pragmatics. One other example is hand gestures and communicative intentions. So there we do things like motion tracking of gestures. We place participants in different situations and we see how their gestures adapt to the pragmatics of the situation. For instance, if they communicate something in a more declarative way, we see whether their gestures are different compared to when they communicate something in a more imperative way. So I think those are the two main fields I can think of within neuropragmatics where virtual reality has also been being used more and more.
Yes, very exciting. Perhaps we could do something like that in Brazil. I don't think there are studies looking at pragmatics in this way here and using virtual reality. So that's all very interesting. Another question, is there any empirical evidence that inhibiting a language actually happens, given the fact that it's hard to define what kind of role one's first language plays in the production of the L2?
Yeah, so there I think the most direct evidence comes from fMRI studies where brain regions that have been quite robustly been linked to cognitive control processes like inhibition really become strongly activated in those kind of tasks that I also showed you. So often, one thing that's hard to distinguish is whether actually there's inhibition going on or whether it's the other way around, so activation of the less dominant language. So that could also hold for those patterns of results, right? So rather than inhibiting your stronger language, it could be that people are just very strongly activating their less dominant language, so that it's become activated more than their native language. I think the fMRI results really link those paradigms and those findings to more brain regions and structures of which we know that they must have something to do with inhibition. So I think that's the most direct, indirect evidence that I could provide for that question.
Okay. What are the future directions for research in VR in the context of psycholinguistics?
Yeah, I hope that it's becoming used more and more in different subfields of psycholinguistics. But I think the main promise would be really looking at different modalities at the same time. So I think in the past, that's something that was ignored quite a bit. So that would be, for instance, certain researchers studying language production and other researchers studying language comprehension, and yet other researchers studying hand gestures and other researchers studying facial expressions. So ideally, I think in VR, in psycholinguistics, all those things would sort of come together in very rich experiments where you can really look at the interaction between those things. So if I'm saying something with a certain facial expression and with a hand gesture at the same time, how do you combine all those things together to sort of understand what I'm saying? I hope that research sort of is going there to be more multimodal.
Do you think that the use of VR would be interesting for individuals of low schooling, low educational levels, for comprehension of the mechanisms and the analysis of the production of discourse? Well, I guess the question is addressing, individuals at low levels of education.
Yeah, I think where it could be particularly relevant, perhaps, is for maybe people who are less literate, who would prefer a more visual environment in which they would learn things rather than just learning something from a book. I'm not sure how it would relate to language learning. I think, for instance, more and more companies are now also using VR. So if you need employees of a certain company to train them in something, I think in more and more companies, this is sometimes happening using VR. So if you have to practice a certain task, you could first practice it in VR before you would do it in the real world, such that if you make a kind of mistake, it's okay because you made it in VR. And if you make a mistake, that's fine. You can just learn from it. Whereas if you would learn something in practice and you would make a mistake, for instance, already if you're working in a shop and you make a mistake, it might have some consequences. So I have a friend, for instance, who works in a VR startup company, and they practice, they train students, pupils, to in terms of being nice to customers. So those pupils, they start wearing a headset, and then they're in a virtual shop, and then customers come towards them, and then they sort of practice how to interact with those customers in a nice way. And then if they say something silly or if they are very rude, then it's okay because they're just doing this to a virtual person. And then once they are trained, they go to the real world. So I think in this sense, perhaps, if you don't like learning things from a book, then maybe this more practical visual environment might be also a nice way for learning things.
Yeah, so this has to do with the next question. Could VR, could interaction in virtual reality environments be detrimental to real social interaction, especially in language learning contexts?
Yeah, good question. I guess we're going to find out over the next months how detrimental it is that we're now just having digital meetings and no real meetings. Yeah, I find that hard to say. So in general, what studies find is that if you experience something in VR or you learn something in VR, the effects will generalize to the real world. So if you practice in VR being a nice person to customers or to somebody, then this generalizes to the real world. At the same time, this is also a pitfall or a danger. So if you would, for instance, do very aggressive 3D games in virtual reality, it might also be the case that this sort of generalizes to the real world. So I think because often people sort of forget for a while that this virtual world is not real, and they might sort of generalize the behavior that they're trained in the virtual world, they might generalize it to the real world. So, but then if they're trained in something good, like learning a language or being nice to customers or what have you, then that might be good. But if they're trained in something that is less preferable, then that might also generalize to the real world. So if you're spending your entire day in a 3D virtual environment and you're just hitting people or so, just because you can, then that might be not a good use of it, actually. A bit similar to computer games.
Mm-hmm. Yeah. In terms of the experiments again, are there any delay issues when using virtual reality, especially for measuring reaction times?
Yeah, so with recent technological advances, the delays are very small. And the nice thing also is that they are stable. So we typically measure what the delay is. And then now with those headsets and with those cave environments, it's usually really in the order of milliseconds. So maybe 30 milliseconds or 50 milliseconds. So the delays are actually very, very small. And because they are stable, we can very nicely correct for them. So we just know, it's a bit technical, but we just know if the computer sends out a command to show a command to show a certain environment, it will take the computer like 30 milliseconds to show it. So since we know this, we can sort of correct for this in the analysis. In the past, this was a much bigger problem because then there were larger delays and then people would get sick because they were expecting something that didn't show up yet, or they moved their head, but the environment didn't adapt yet to what they were looking. But with the latest advances, those are just very minor problems that can be corrected for.
Okay, the last two questions. Some language phenomena are studied in isolation. So a shift to a virtual reality paradigm to study such phenomena could lead to different evidence and novel theoretical implications. Would you agree with that?
Yeah, definitely. Yeah, I think in the studies that I showed, we found the same results as before, which in a sense is nice because it sort of confirms the theories that we have. But in certain other cases, sometimes we find something novel or something that's not being confirmed. And I think all the theories that we have, they will still hold. It's just the question is to what kind of situations are they relevant? So maybe in the worst case, a theory that is built on the basis of those traditional paradigms, it just holds for those very static situations, and maybe they're not so relevant for everyday life. And in the best possible situation, even if we make the paradigm super rich, still we find the same thing. So then the original theories that we had would also be relevant for the more realistic situations. Sometimes people then say, yeah, why are you doing this in VR if you're still finding exactly the same thing? Well, once you have done it, then you can know for sure that perhaps your theory generalizes to a bit more richer situations. If you wouldn't have done that study, you would never know, I think.
Yeah, so that was actually my question, because, well, it's good to see that the results are the same in VR, but at the same time, you are replicating what we already knew in the lab, right? The last question, David, is, could it be that bilinguals train more to suppress their L1 due to the learning process, and that is why it could be easier than suppressing their L2?
I think that very much depends on the time they use the two languages in their everyday life. So if I think of students now in the Netherlands who would have Dutch as their native language, many study programs are now completely in English, also to be open to foreign students. So I guess if students are really doing this all day, conversing in their second language, and maybe only use their first language when they are at home with their parents, for instance, then they might be suppressing their dominant language more than others who are only incidentally using their second language. So I think the percentage or the proportion of time you use the two languages should definitely have an impact on sort of what findings you will find in the end. Yeah.
Okay, fascinating. There's a lot to explore. So people can always reach out to you for references, for advice on new experiments, right? So David,
find me on Twitter or
so he is on Twitter, and he is a young researcher, very promising one, so a rising star. Be in contact with him. Again, David, I'd like to thank you for accepting our invitation to talk to us today, for opening the series. I'd like to thank the audience. I'm very happy to see my colleagues in the psycholinguistic community in Brazil here. So yeah, thank you so much for your time.
Thank you for the very nice organization.
Your final words to the audience.
Oh, wow. Well, thanks a lot for attending. It's a pity we could not meet in the real world. I hope you still enjoyed it. And most importantly, I hope you'll stay healthy and stay fascinated by language research in general.
Okay, then. Thank you so much. And bye-bye. Next week at 2 p.m., we have another lecture in the series. See you all then on the 9th of July. Thank you, David, again.
Thank you.